Today we're looking at trapezoids and kites. This is the last type of quadrilateral for Unit 6. First, we're going to look at the mid-segment. So the mid-segment of a trapezoid is the segment connecting the midpoints of the legs of a trapezoid. So it's connecting the midpoints of the legs of the trapezoid. That's the mid-segment. It's also known as a median. So in the diagram, it's the segment MN. So M is a midpoint and N is a midpoint. So you could also label that. M is the midpoint of HL, so from H to M is the same as L to M. And N is a midpoint of JK, so those two sections are the same length. We don't know that they are all four congruent, so we're going to put them separate unless it's isosceles, which is the next section. It's isosceles. That means that the two legs are the same length. Just like with an isosceles triangle, the two legs were the same. And there is a formula. So the mid-segment, or the median, just like the median of the road splits the road exactly in the middle. The mid-segment is equal to 1/2 of B1 plus B2. Base 1 plus base 2. Where the parallel sides are the bases. So the top here, there's the parallel pieces. So it doesn't matter which one you call base 1 and base 2, but this is, I'm going to call this base 1, and I'll call this base 2. Sometimes it's the top and bottom, but if the trapezoid is rotated, then it's not necessarily the top and the bottom. So it's the average of the bases. You add them together and divide by 2. And next we're going to have, we have isosceles trapezoid. So isosceles trapezoid, just like an isosceles triangle, tells us that the legs are the same length. So the parts that are not the bases are the legs. And that's all over here in this diagram. So we have the legs are the side pieces, and we see that they're congruent if it is an isosceles trapezoid. And there's a base on top and a base on bottom. That's the parallel pieces. And then for all trapezoids, there is exactly one pair of parallel sides. All right, so that is for all trapezoids. Now, isosceles trapezoids have 3 additional characteristics. One is that the legs are congruent. Another one is that both sets of base angles are congruent. Just like in the isosceles triangle. So in the diagram, angle R is going to be congruent to angle U because those are base angles and they share the same base. And then S is going to be congruent to T, but not congruent to R and U. And the third characteristic of isosceles trapezoid is that diagonals are congruent. And that's just for isosceles trapezoids. Okay, so we're going to go ahead and just look at some examples of how to work with trapezoids. Here we have, it says find the measure of angle D. Angle D is down here. But all we have is that angle A is 125 degrees. And we're trying to figure out angle D. So we know base angles are congruent, so that tells us that angle B is also 125 degrees. But that really doesn't help us with D yet. But we can do the same side supplementary with parallel lines. And the consecutive angles are going to have a sum of 180. So if we take these two angles B and D and add them together, it's 180 degrees. So if the top one, B, is 125, do 180 minus the 125, and that gives us angle D, which is 55 degrees. So we know the angle D is 55 degrees, and then we also know that angle C is congruent to angle D, so that would also be 55 degrees. All right.
Is the whole trapezoid 180?
A trapezoid is a quadrilateral, has four sides, so it's going to have 360 degrees together.
Okay.
So each side, so the total is 360 degrees. You can kind of think about it like splitting it down the middle, and then each side would be 180. So 180 on that side.
So all sides add up to 3 sides.
So,
And
so
this side.
could you also have done like 125 plus 125, and then like the sum of that subtracted from 180, and then divide that in half?
Yep, that's another way of doing it. But when you have an isosceles, the dashed line that I just drew kind of works as a line of symmetry, so everything over here is going to be the same. But the symmetry only works when it's isosceles. All right, so another one says find measure of angle L. That would be this angle. There's nothing there, but we do have angle K is 40 degrees. So we can use that same property, because we can see that this is 5 and this is 5, so that means it's isosceles. So because it's isosceles, we can do the same thing again. 180, take away the 40. So that means the angle L is 140 degrees. Okay, so for number 3, there was a typo I noticed on what it was. It said an isosceles trapezoid ABCD on your paper, but if you look at the trapezoid, that's not trapezoid ABCD, it's ABDC. So I fixed it on my paper, and then I copied and pasted the trapezoid down here. So whenever you sketch yours, you should sketch it as ABDC, going clockwise. And then we can do this. So it says AD equals 12x minus 11. So A to D is the diagonal. And then BC is 9x minus 2. BC is the other diagonal. And because we have this marked as isosceles, we can look at the properties of isosceles trapezoids, and it tells us that the diagonals are congruent. So because diagonals are congruent, we can set AD equal to BC. So 12x minus 11 equals 9x minus 2. And then we can solve. So I'm going to add 2. Hold on. I'm going to start with the 9. Subtract 9x. So 3x minus 11 equals negative 2. And then I can add 11. Put it up here. So 3x equals 9. And then divide it by 3. And 9 divided by 3 is 3. So x equals 3. And that is what it said to solve for, so that's that. Again, when I went back to these notes, I copied and pasted the trapezoid because it's better to have a new figure for every problem. Here we have trapezoid HJKL. M and N are midpoints of the legs. It tells us that M and N are midpoints of the legs. So M is in the middle of HL, so that means each side of M is congruent to each other. N is in the middle of JK, so each side of N is congruent to the other. All right, and then it says if HJ equals 32, so HJ is 32, and LK is 60. So here's L to K. That's 60. Find MN. All right, so I know MN is right here, but I don't know what that length is, so I'm going to make it an X. And this is where the mid-segment or median formula comes into play. The mid-segment equals 1/2 of B1 plus B2. All right, so if we look at the picture and we plug in to the variables, so the mid-segment, that's X, that's the piece in the middle from M to N. So X equals 1/2 of B1 plus B2. It doesn't matter which one you call B1, B2, as long as it's the parallel pieces. So I'm going to call 32 my B1. And plus B2 is 60. That's my B2. Since we're just adding those two numbers together, it doesn't matter which one you call B1 and B2. So we're calculating the length of the mid-segment. So we add those together, so that's 92, and 1/2 of 92 gives us 46. So we get that X equals 46. All right, so that's one type of mid-segment or median problem. The next one, so go ahead and sketch the trapezoid, real quick sketch. And this time it says that HJ, the top piece, is 18. And MN is 28. Well, MN is the mid-segment. And it's asking us to find the length of LK. That's what we don't know this time. So that's where the X is. So we're using the same formula. I'm going to abbreviate mid-segment as just mid. So mid equals 1/2 of B1 plus B2. But make sure you plug the information into the correct places. The mid-segment, I know what that is. That's not X anymore. The mid-segment is 28. I already know what that is. And that's going to equal 1/2 of B1 plus B2. B1, again, I'm just going to stick with the top piece. It doesn't matter which one's which. It's 18. And B2 is my bottom piece. That's X. So now X is inside parentheses. It looks like it's the same kind of problem, but it's the same formula. It's just a different kind of problem. So make sure you don't just take the two numbers and plug it in for B1, B2. You put them in the right places. So this time I need to solve. I'm going to start off with solving. So I have reverse order of operations. I'm not going to inside parentheses first. I'm getting rid of the 1/2 first. So that's kind of like 1 divided by 2. To cancel out half, you would multiply by 2. So I'm going to say times 2 to get rid of the 1/2. If I do it on one side, I have to do it on the other side. So 56 equals 18 plus X. And then I can subtract 18. And then I get that X equals 38. And that is LK. All right, so that's the kind of problems you'll see for trapezoids, is mid-segments and finding the missing angles or diagonals. Next is kites. So first we need properties of kites. The first property is that there are two pairs of consecutive, meaning one right after another, congruent sides. Two pair of consecutive congruent sides. So that means the two sides are going to share one endpoint. So I see that P to N has one line, and N to M has one line. There's one pair of consecutive congruent sides. And then M to R has two lines, and R to P has two lines. So there's the second pair of consecutive congruent sides. The next one is that diagonals are perpendicular. So that means 90 degrees, right? Just like with a rhombus, the diagonals are going to make 90 degrees in the middle. So it's going to look like that. So that means we have a lot of right triangles that are going to help us in solving with kites. And then the last characteristic is one pair of opposite angles are congruent. All right, and it's the opposite angles that are on the short axis. When I say axis, it's the short diagonal. You have a short diagonal and a long diagonal. The short diagonal is where you're going to find the one pair of opposite angles that are congruent. So this one is congruent to this one, not the others. The long way, those do not have congruent angles. It's the short way. All right, so that's your three properties for kites. All right, so I copied and pasted the kite. So at 4, I'm going to switch over to a new kite. I'm going to do 1 through 3 on this kite. All right, so let's find the measure of JRK. So first we have to figure out where it is. Here's J, here's R, here's K. So that means in the middle. So it's right here. That's the angle I'm talking about. What's the measure of that angle? 90 degrees. So that was pretty easy to find. And it's because diagonals are perpendicular. Okay, so then number 2 says, if RJ is 3, all right, so where's RJ? Here's R, there's J, this section right here, if that has a length of 3, And RK has a length of 10. There's K at the bottom. So that's a length of 10. Find JK. So JK, it's right here. That's what I'm looking for. So I have a right triangle. So when you have a right triangle, you can use the Pythagorean theorem. A squared plus B squared equals C squared. It doesn't matter which leg you call A and B. What does matter is that you call C the longest piece, and it's the one that's across from 90. In this case, that's the x. So it's going to be x squared has to be in the position for C. The other two, it doesn't matter. So I'm just going to say that A is the 3, so 3 squared, and B is the 10. So 3 squared plus 10 squared equals x squared. 3 squared is 9, plus 10 squared is 100, so that's 109, equals x squared. But I'm not looking for x squared. I need to know what the value of x is, because that's the length, the missing length. So I have to take the square root to cancel out the squared. So it's going to be the square root of 109. And I'm just going to leave it like that. I'm not going to worry about simplifying that. So x equals the square root of 109. All right, so number 3, now we're talking about some angles. We have the measure of the angle GHJ is 90. GHJ. That is this one up here. That's 90 degrees. So I'm going to write 90 up by the H. I think that'll be a little more clear. That's 90 degrees. And I have the measure of GKJ is 110. G to K to J. So now I'm down here in the bottom. This angle is 110 degrees. Find the measure of HGK. HGK is on the left. This is the one I want to find. All right, so how could I, oh, I still have to do there because it is different. So now I'm just looking at the top angle is 90, the bottom angle is 110, and the left angle is, I don't know, I want to find that. So I gotta think about, like, how can I do that? There's only one more angle, and is there a relationship in a kite that will give me some information? A characteristic of kites about angles. Well, one of them is diagonals are perpendicular, but all 3 of these are on the outside. Nothing's really, there's no sides involved. It doesn't really sound like I'm looking inside the kite. It looks like I'm looking around the kite. One pair of opposite angles are congruent. That seems helpful, right? Because it's the short diagonal. So that means that the J is going to be the same as G. And I know H and K. And how many angles are in a kite? Like, how many degrees are in a kite?
360.
360, because it has 4 sides. Right? So there's 4 angles. So N would be 4. So the sum of a quadrilateral is 360 degrees. So if I started with 360 degrees and I subtract the 90 from the top angle H, yeah, and then I also subtract the 110, and it gives me 160. So now I have 160 degrees left over, but I have 2 angles. And I know those 2 angles have to be exactly the same. So what should I do with it? Yeah. Divide it by what? 2. So I'm splitting it exactly in half. So each one of them is 80 degrees.
So now it's all even, right?
Yeah. because that uses all 360 degrees and it matches the properties. So HGK equals 80 degrees. All right, so this is why I made a new kite, because that one has a lot on it. So I'm just starting over with a new one. If HJ equals 7, so HJ has a length of 7. Find HG. Yep, it is 7, you're right. Because I know that there's 2 pairs of congruent sides, and these are consecutive congruent sides. So it has to be 7. So HR also equals 7. All right, then if the measure of angle GHJ, I need a different color. G to H to J, so it's this angle, is 52 degrees. And the measure of GKJ is 95. G to K to J. So this one down here at the bottom angle is 95 degrees. Find HGK. This is like the same problem, right? Yeah, this is just like the other one. Okay, so we're going to find HGK. So it's this one. So we do exactly the same as that one we just did. So 360, subtract the top angle, 52. Subtract the bottom angle, 95. And that's going to give us 213. We take that 213, we cut it in half because those other 2 angles are the same. So it's 106.5 degrees, which is kind of weird, but that's what it is. Angle HGK is 106.5 degrees. And that is trapezoids and kites.